Yeah.
Oh, okay.
Use the link I
Wow,
just sent in
that's really
chat
cool.
in Foothill.
Really cool and quick. Caitlin actually sets up these meetings sometimes in this other project thing that we're working on. So she's kind of coordinating the all of these things, and I'm pleasantly surprised. I just hop from one meeting to another, and all the people are there already. It's actually a new experience for me because most of the time, I have to go and wait and so on. It's really cool. It's working nicely. Thank you.
Just click fork this in the top left.
Comments. Get rid of all the comments. Oh, yeah, you have the comments. Yeah, you can have the comments. Okay, so you're going to type all of these. Now, neither Caitlin or me or who was the other person? Josh, okay? We'll say anything unless you ask for it, but someone else, hopefully, and maybe not even Matthias, okay? So not Matthias. Yeah, and not all the people who have already had a chance. Someone else should just say, this is what you got to type. And then Jonas is going to type that, okay? Hey, control plus or command plus one more time. Control plus one time.
Yeah.
One time. Yeah, no. Yeah, that's enough. Right. Okay. So Jonas is going to fill this in. Okay. Everybody will get a chance after Jonas is done. Someone else, maybe before Fred joins, you can do that. And when Fred joins, obviously, I'll say hi to him, and then I'll basically leave the meeting. Okay, I'm going to leave this meeting. Maybe hand over to someone else. The host thing, I'll leave because you can have a frank conversation with Fred. He was a student 4 years ago. I'm actually eager to see him now because it's after 4 years. I've never seen him. So his for the first batch of students after COVID. So I was teaching entirely online and then no Zoom, only online and no Zoom. And I had questing, no Zoom at all, but only online. And he did that ABC track at that time. So I never actually got to see him face to face. It's the first time. It'll be very surprising. After he went and did his master's, he comes back, and that's when I actually get to see him. So funny. I'll let him know that. Okay. Now you can carry on and code this, okay? Jonas, go ahead and code, okay? Someone else should call the code. Manya, whoever, Mark, Ian, anybody who understands what is going on, code it. And then what I can do is also start stepping in if you have questions, saying, hey, Prof, can you explain this? Can you explain this, okay? And maybe after Jonas, I'll explain it. Or maybe on Thursday, I'll explain it. After you've got a bit of experience and just throwing things together and getting it to work, I'll explain it. And by the way, there was something in the last program that I wanted to correct, or at least do differently, but we'll do it this time, okay? Because I think, if I remember correctly, you were calculating the average in integer space. Everything was an integer. Yeah. So there's a lot of clipping going on there. So what I was going to suggest was this time calculate the average in floating point space, okay? Again, this is where all your data representation knowledge comes in useful, okay? You have to make sure that either the numerator or the denominator in your division is a floating point number. Otherwise, division will happen in integer space, which has no room. In an integer, there's no, no mantissa and exponent, yes? An integer, all bits are used for the number, the magnitude. So if you divide an integer space, anything that's fractional is thrown away. You can't represent it. So you got to make sure that the division happens in floating point space, and then you should have a floating point fractional number as your average ASCII value. You should get a fractional number. So this time, print the fractional number out, and then once you get the fractional number, we'll try and figure out a way to convert that to a bigger 5-digit number or something like that, okay? Which will make more sense as a pin number or something that's interesting for you to print out. Because last time I kind of overheard that you were getting numbers like 107 and we're trying to 4 A's in a row to get 65. Even if you have any number of A's, you should get 65. Yes, because it's all divided by the length. That's what you're doing. But then we'll try and scale that into a range of, I don't know, 99999, okay, or 10,000. So you get enough digits to in your lucky number. Okay, so that's what you're going to do. How about someone else? Jonas, just be in the capacity of typist. Okay, don't type ahead at all, and force people to call out what the code is that you should type. Is that okay with you?
Yeah.
Great. Okay, so you guys take it away. Okay, so I'm gonna I had half a mind to just turn it around so that I'm not in your face. But if I turn it around, I won't know if Fred joins us. Hang on. Yeah, I won't know if Fred joins us if I turn it around. Unless you guys, are you going to be talking, right? When Fred comes here, if you're going to say, hey, Fred, let's call the prof, right? Or something like that, I can come back. That way I won't be in your face. Also, I will be there to, you know, if when you ask for explanations of what these things do inside of the program, when you ask for explanation, what was that beeping sound? Did you hear a beeping sound just now? I don't know where that came from. Anyway, yeah. So as far as the explanations go, we'll focus on the explanations of everything inside of main. Okay, and the one thing that we should keep in mind, which we didn't cover, is that a C++ program essentially starts off in a place called main. Okay, the main part of your program where your program starts its execution is special, and it goes by the special name main. Okay, so if you have a function called main, and every function looks like that, okay, a function says, I am a function, my name is main. Okay, just remember this, and someone should remember this and make a note and write on the Reddit too. It'll seal it in your own memory and also help other students. Okay, so this is what the function means, that signature. That function says main, right? My name is main. When someone says call main, call me. That's what the name main means, okay? Different functions have different names. How do you know it's a function? It's got parentheses immediately after the name. Now, in this case, they're empty, but it's not always the case that they're empty. Sometimes a function may be called and say, hey, function, do this with the color red. Hey, function, do this, the same thing with the color blue. So you may give it different parameters, just like another, right? So in this case, we're saying, well, just do it, right? Just do it, just like do it Nike, right? Just do it, right? No parameters. So in that case, empty parentheses. So let's main easiest for beginners to just say no parameters. Okay, we'll talk about cases where main also takes parameters later on. So empty parentheses. After main is finished, what is the value that it returns to the operating system or the person that calls main? What is the value that it returns? Hey, this is the value, right? So that is the type of the value. Is it returning a string? Is it returning an integer, a character, whatever it is, right? The type of that goes in front of the name, right? So it says, my name is main, right? I'm taking no parameters. And when I'm done, I'm going to return to you, the caller, something that is of type integer. That's what that line means. Is everybody okay with this? This is how the compiler understands this program and turns this into machine instructions that will be executed by the CPU. All right. So the compiler basically turned those into machine instructions, but this is what the grammar is. This is what it's looking for. So essentially, the compiler follows the grammar. As this is what you should look for. If anything looks, off, it doesn't follow the grammar, you just, it'll spew a lot of rubbish at us saying, well, I don't understand, syntax error, reading. That's because the compiler doesn't understand. And I think, I've made this point to the previous students also. It's just that they have to just get used to all the reading by the compiler. It's very intimidating for non-C++ programmers who come to C++, because in some of the other languages, the error reporting is more benign. Okay, they tend to sugarcoat it and try to explain it more. Whereas C++, they kind of explain. I don't know. The compiler designers kind of assume that for someone who is bold enough to program in C++ is also strong enough to understand these messages and not get scared away by them. So many of these messages are cryptic and also voluminous, right? They might give you like that many messages, which all because you missed a semicolon somewhere. Okay, and it actually happens. So one of the things that beginning programmers also have to get used to with C++ is that the volume of the messages that you get from the compiler. Of course, if you don't get any messages, that means perfect, no errors at all. No news is good news. That is a Unix philosophy, right? That means that if you didn't get any error messages, fine, your program didn't have any errors. But you do have errors, you'll get messages. C++, you get lots of messages, sometimes cryptic, make you look like you didn't know what you're doing. All of those things, you just have to get used to it. Okay, we just have to get used to, but that's not what it is. In the future, see, all these compilers will have some kind of an AI wrapper around that. and we'll basically look at your program and also look at the error message and describe it to us in a way that is suitable to us. But yeah, well, one of the things that I've found in a previous research project that I was involved in is that novices like clear error messages, all broken down and explained very clearly. But very soon, as the person gets more and more expertise in the field, they want everything trimmed down. Say, just cut the fluff and give me the facts alone, right? I'm going to deal with just the information. Don't give me any extra, fluff like I do in my lectures. And you'll find that happening. So initially, when you use a user interface, beginners greatly appreciate getting a lot of information, saying, well, don't do this, and so on. But after a while, it gets more tedious to have these things interrupt, and you know what you're doing, and you make a single mistake, and the system says, no, that's it, right? I'm not going to do it. There's something wrong. You don't want it to explain. That is actually much faster and more convenient. So people start preferring user interfaces that are more terse. And I did this research a long time ago with some teammates in the area of the Unix operating system. Because Unix is actually famous for its very terse error messages. It's an operating system where the error messages are designed to be as brief as possible. Don't give too much information, because we find that expert users, who typically are the users who use operating systems like Unix and Linux eventually, also tend to be, don't be verbose unless I ask for it. The default behavior is to be terse and say, well, if there's everything is okay, don't say anything at all. No news is good news. So that is a very good programming philosophy in general, I think, and that experts tend to, as you get more and more comfortable with the language, that is the behavior that you will yourself find yourself drifting towards. Okay. So I don't know how we got started talking about that. So that's basically what, yeah, right. So that's a signature. Oh, and finally it says, my name is main, and I'm going to return a type of, a value of type int, that return 0 at the end. That's what it means. Okay. Return 0 says, hey, I'm going to return a type of value integer. 0 is an integer, return it. All right. Now it doesn't have to be 0. It can actually be any number. It can be return 47. And then you'll have, main will return 47. So each of these, that number return, and the reason you have the facility for a programmer to return different values is that you can signal back to the operating system that calls main, say, hey, main, or hey, program, whatever this program is. Okay. Who's coding right now? Jonas, right? Hey, Jonas's program. When you run, you're going to return a value. Hey, Masi. Oh, I didn't realize. Are you in this class? I don't know. Oh, anyway, all right, okay. Where's Fred? Okay, yeah. If Fred comes here, someone should let me know, because if I'm not seeing him on screen, I won't be able to. And maybe he will be polite and say, well, I don't want to interrupt when the prof is speaking. What time is it? 7:30. Maybe he's going to join anytime now. Oh, Rebecca is here. Okay. Hey, Rebecca is my former student. She actually finished 2B. She's here to meet Fred. Hey, I had a couple of other people might also join us to meet Fred. In fact, Rebecca, Isidore, Caitlin, Josh, all of these people who are my students, they're on the Reddit too. So you should actually totally feel free to ask any of them for help. Even I'm pretty sure they're all doing other classes and doing research projects and all these other things at Foothill too. But I'm pretty sure they will all be happy to help you, right? If you say, hey, Caitlin, you can tag people on on Reddit too in your posts. You can say, hey, can you help me with this? Can you help me with this? The only request I have is that record it so that other students can also help, benefit. Hey, where is my phone? Oh, my phone is over there. Where's, why is, Fred should be here. I hope he's not, stuck or anything and asking, oh, I got an email. Maybe I hope it's not Fred asking, hey, where do I come? Right. Okay. No. Anyway, go ahead and code. Okay. Go ahead and code and until Fred comes here. Okay. I'm just going to keep an eye on the participants screen. Rohit, I didn't get the link. Can you please share the link to me? Rohit, are you here?
Yes, sir.
So what link are you talking about? You're here now.
Yeah. I just got a link from Wendy. She shared the link.
Oh, who is this? Oh, Marcy. Marcy. Will you speak again? Rohit, speak again.
Yes, sir.
Oh, wow. Okay. All right. So on my screen, you're showing up as Marcy Mosley.
No, it's just a
No?
random name maybe.
Hey, other people, because someone else tell me if Marcy is showing up as Rohit.
Yeah, it's me. My name is, I don't know how.
Professor,
Yeah.
Fred is here.
Fred is here. Where is he? Fred, where are you? Let me maximize my screen here for a sec.
I don't know why my name is showing like Mossy.
Yeah, I don't know, because Marcy was my student from previous quarter. So
I don't know. I just signed in.
it.
Oh, maybe someone share the link, and when I join,
Yeah,
it
that's
shows
why,
us like
you know,
this.
great. Okay. Never mind. Since you're here, and we know you're not Marcy, you are
Rohit.
Rohit, right? And Puneet was also looking for a link at some point, I think. I know Puneet. Anyway, Fred. Where's Fred? I saw Fred a minute ago.
Can you hear me?
Hey, Fred. Okay, I can see you now. All right. Okay, let me actually maximize the screen, and I will actually step out in a minute. Okay, I just want to say hi to you and introduce you to the to the class and step out, and then you guys can have a frank conversation after that. And by the way, welcome, Wesley. Welcome. Okay, Rebecca. My past students who have come back to meet Fred. So, and believe it or not, Fred, I was telling my students today that I've never seen you face to face. Even though you've done all of my ABC classes, right? And because he I think it was the first batch or the second batch of students to test with the questing system after I created it, and COVID had just sprung up on us at that time, and so we were all teaching from home, and I was doing all online classes, but we didn't have Zoom at that time. So this was a period before from face to face and then to online and no Zoom. So I never got to see Fred, but we interacted so much on the Reddit, and you got a bunch of really fun things to say. So I look forward to that. Thank you all. Thank you for coming. It looks like you had a great time at Georgia Tech. Yeah, okay. So I'm actually glad to see you. Did you major in data science or machine learning or something like that?
At Georgia Tech?
Yeah.
My specialization was computing systems.
I see.
Yeah, so it was a little bit more on, I was interested in like the systems programming side, so operating systems and things like that. But they do have, excuse me, they do have an analytics program for people that are interested in data science. And then within the CS degree, there's artificial intelligence and machine learning, a couple of different specializations. So
fantastic. Because all of the students who do the introductions in Canvas, they say my goal is to go and do data engineering or machine learning at Georgia Tech. And I thought, well, you know what? Everybody's saying this at Georgia Tech. And then there was a news article saying NVIDIA was going to invest in in Georgia Tech.
Yeah, they just built some makerspace, basically a fancy makerspace, but instead of 3D printers, it's I think they're supercomputers, AI computing clusters, which is pretty cool.
Wow, very nice. I'm actually absolutely glad to see you come back and also talk to our students.
Of course.
Yeah. So if you have any questions for me, I'm just glad to see you and to see someone who's actually done this and gone on and and dive deep into one of the areas of interest. Okay, and that's what I also tend to tell all these students too, is to not to spread themselves thin and say I'm going to be in 5 different clubs and do many different courses, but take some areas and go deep in it. Other areas you should choose to occupy your time, but not go deep in. That will give you more time to go in this. That is what I've been trying to push to with these students, and they can obviously check these with you too.
Yeah, I think that's a great piece of advice.
I will, unless any of you guys have a question for me and Fred together, or Fred has a question for me, I would basically just have, welcome, Fred back to our class and the opportunity to see him face to face. And this is it being recorded? I don't know. Is this being recorded?
I see recording on my screen.
It is okay. Well, on my screen it says it's not recording, but maybe it will be recorded in the cloud. But if it is, we'll make it available for people who ask. Say, hey, are there any recordings from past students or something like that? So we'll absolutely make it available. And also, these students can talk to their classmates who are not able to make it. So feel free to ask Fred any questions you may have, about generally, this track, whether it's worth pursuing, learning computer science, Georgia Tech, anything, all of these things that you may be savoring to ask some of your senior students. Okay, so then think about those things and ask Fred. Okay, so fantastic. I've had a great time teaching Fred, the entire batch, but also responsive and interactive students like Fred. Okay, so that's what I mean. If you go back to the Reddit and see, there are a bunch of students who basically just get by all the quests and do all the quests, no interaction with other people, just treat it as one lead code problem after another. Okay, it's not like lead code at all, because lead code is focused on a different thing. You can cut edges, you don't have to be elegant, you have to, right? And but that's no fun at all. So the students who actually are fun, not just for other people, for themselves too, are the ones who leave a trail of breadcrumbs. Yeah, and so if you go back and look, even the Fred Hoffmann Reddit, right? So you can see all of the posts he's done all the way from the Blue Quest, and it's actually fantastic. Okay, it's and if you look at it, so I actually have read many of Fred's posts more than once. In fact, he made a research post about Valgrind at one point. This is the first time someone encountered memory errors and how to get to the bottom of memory errors. Which you will encounter after you do quest number 9. You'll start encountering memory errors. And so Fred did some research and discovered some tools, and he talked about Valgrind. And that is, in fact, the code tool that we use in questing too. It's there.
I've used it a lot, especially if you're doing any kind of C, C++. You do it at Georgia Tech, and I'll tell you that memory errors don't stop here. You'll run into them all the time.
Yeah, so it's best to get used to them, right? It's just and just say, treat it as just another thing, and say, well, all right, I got 5 errors to fix, so it's going to take me like 10 minutes or whatever it is, right?
Yep, part of life.
Part of life, exactly. So yeah, that's fantastic. Okay, I'm grateful for anything any of you say in these recordings, because people will be coming back to these things, referring to them. And use the wisdom from people who've actually gone through the system and learned so much more to come back and share with their own formal selves. Because, when Fred looks at you guys, in a sense, he can actually look at a snapshot of himself from 4 years ago and say, well, there are certain things that I wish I had known 4 years ago that would have saved me a year of time. That year I could put to use to do my startup or whatever it is, some idea, right?
Right.
So there are things like, the recurrent neural networks, okay? Because, when we process patterns in sequential data, with neural networks, you can do sequential data. Well, I don't know, we shouldn't get into that. But going back, reflecting on the past and doing that made all the difference. It made a huge jump in performance, right? So that's what we bring to the table, even in learning, in our human learning. We just go forward. But if you can go back in time and say, right, well, you know what, I'm just after 4 years, I got lots of information, but I can shave 1 year of those 4 years if I go back in time, like Back to the Future, Marty McFly, and say, you follow this, okay? Shave 1 year off. Okay, so Fred is our Marty McFly. Okay,
Here we go.
He's come back to give you the gift of 1 year. Okay, so think of yourself on your deathbed and say, well, you know what, 1 more year, maybe I'll do some cool stuff. Fred is here to give you that 1 year, so you can take that and roll with that. Okay, so thank you, Fred, for coming in.
Thank you for inviting me. I'm happy to be here.
Yeah, and also, you should feel free to talk to your classmates if you're in touch with them. Rick came by, Rick Morris. He was your classmate, I think. Yeah,
I believe so. That name sounds familiar. Yeah.
Yeah, he completed his master's at Georgia Tech a couple of years ago, maybe. And he was also in the Army, I think, or he's the Armed Forces. So he came back to talk to our classmates at one point. But I think you guys should basically just talk to your classmates too, anyone you're in touch with, and say, hey, go back and talk to our CS2A students, because there's space at the end of our lectures, just like this. And if you have a free moment, come and talk. It's all gold nuggets for students to hear their seniors. Okay.
I hope that it's useful. Yeah.
Thank you. Frank, you have a question for me or for Fred?
For Fred.
Okay, I'll take off. Okay, so you guys can have a frank conversation. You can talk about anything you want. All right.
Okay.
All right. Is that good? All right. Let me see if I can get something here. Right. Fireworks for 2 thumbs up. Okay. I get fireworks for 2 thumbs up. Okay. All right. See you guys later. Bye.
Bye. Yeah,
So,
go ahead with the question.
so thanks for coming, by the way, and speaking to us. But I just wanted to know from your experience. So the first question is like, what are you doing now, and when did you graduate? And then the second question is, if like, what do you think was the most valuable thing you got from your master's?
Yeah, so I kind of made some slides to go over what I'm about, just in case it helps people. But I can answer both of those questions. Let me see. It's been a while since I've been on this end of a Zoom meeting. So how do you guys usually like? If you guys have questions, do you do the raise hand thing, or do people just ask? I guess there's not that many of you guys, so
People have normally just been asking, but I mean, we could do the hand raising thing if you'd
I
like.
just whatever you guys are most comfortable with. There's only 25 or 24 people here, so I think that people probably won't step on each other's toes. So I'm happy if people just want to pipe up. Um, so let me see if I could share my screen. Can you guys see that?
Yep, we
Yeah.
can see it.
Yeah, we
Cool.
see it.
Cool. And then that should be like full screen for you guys.
Yes.
Yeah.
Nice. Okay. So about me, I'm Fred. I graduated from UC Santa Barbara in 2017, and then was working at Lockheed Martin for a little while. That's kind of where I fell in love with coding or got interested in it, so to speak. And so I enrolled in Foothill online right when COVID started, in preparation to go to Georgia Tech because while they have a pretty loose admissions like criteria, they do like to see kind of some coursework that shows at least you're interested in coding. So I went to Foothill and I took the entire 2 series. I think it's 2A, 2B, and 2C, at least when I was there. So I finished that basically in 2020. I think I just did 3, like a spring, summer, fall semester. You guys are on semesters, right? I think so.
We're quarters.
You guys are on quarters? Okay, so it's 3 quarters
Yeah.
then. I always forget. Georgia Tech is on semester, so I'm all in semester mode. And so I started at Georgia Tech in January of 2021, and then basically took, with the exception of 1 semester, I took 1 class a semester, and so I just finished my last exam of my last class. So technically, I'll get my degree on like May 8th or something like that of this year. So I guess technically speaking, I haven't graduated yet, but there's nothing left for me to do except wait for the degree to come in the mail. So I started out at a small company called Appfolio, not doing anything technical. Nobody knows what to do with the physics major. So I was trying to figure out what I wanted to do myself, and that was paying the bills. There's a Lockheed Martin in Santa Barbara where I went to school, which is where I was living. So they took a chance on me and hired me, and I got to do a lot of coding and like Python and MATLAB. Like I said, I like that. So I worked at Lockheed Martin for about half the time that I was going to Georgia Tech and at Foothill. And then I landed a job at AWS, Amazon Web Services, as a software development engineer. Probably a question on everyone's mind is, do I think that the master's had anything to do with that? I think it definitely did. Whether or not it prepared me is a whole other conversation that I can go into. But having something that says computer science and an accredited degree on a resume, I think, for better or for worse, I don't think it makes anyone a better or worse programmer, but I think companies with their what they like to see on applicant resumes and stuff like that, I think that there is some value, at least in Amazon's case. Unfortunately, and I'm sure if you guys have probably been pretty plugged in, the tech market right now is kind of topsy-turvy. So 9,000 of us got laid off, including myself, back in June of last year. So I picked up a contract job that I made with a friend at a small shop called AppStem, and I've just been working there ever since, just to kind of keep my skills up. I do have a couple interviews, so people are still looking. It seems like the market is picking up. But yeah, so since then I've done coding at Lockheed Martin, Amazon Web Services, and then just kind of keeping my feet wet in back-end programming at this company called AppStem. So that kind of answers your first question, I think. Going on, what was the most valuable thing that I learned in my degree? Was that your second question?
Yep.
Okay. The most valuable thing I learned, actually, you could look at that 2 ways. I think overall, the thing that's going to serve me the best, like throughout my career, or if I want to go back to school, is actually the practice of having to learn things yourself and having to pick up things yourself. Georgia Tech is very much a sink or swim program. They kind of let you know what they're expecting of incoming students at the beginning, and they're pretty loose about who they let in. A lot of people end up not finishing the program just because they find that they need to go back and re-solidify some concepts. So having that skill to go and quickly identify that you don't understand something and then drill down into why you don't understand it and basically like learn what to Google or what textbook to read is really valuable, because I think that's just kind of what happens. Like I found that happens at Amazon and at Lockheed Martin and at AppStem. There's always going to be stuff that you don't know. And so the quicker that you can identify it and the quicker you can get yourself up to speed is paramount. And being in a degree like this really helps you hone those skills. Just trying to think through problems about, okay, what exactly is the part of the problem that like I'm not getting? What is that called? What is this concept called? How do I even find out the name of that concept? Second thing I would say that was most useful in terms of like actual career software engineering stuff is just, so a lot of the courses are project based. So much like this class, you just end up writing a lot of code, and the more code you write, the more design patterns you get exposed to, just the more you become familiar with whatever the languages are and the syntax, and you can recall it quicker. And then I think one strength that I unfortunately didn't get to take that much advantage of because I got in 2021 and they've had another 4 years to develop the program, is that they are adding more and more courses. There's always going to be a lag between like academics and then what's actually going on in the industry. But I think they do a pretty good job of at least adding like survey level courses. So they have one on like natural language processing and large language models nowadays, which like ChatGPT, kind of blew up. So that wasn't available when I was taking courses. It is available now. So I think that those kinds of classes can help you stay on top of like what the industry is doing, provided that they offer them. Does that make sense? Cool. 1 sec. My phone's ringing. Okay, we're good. So yeah, the program that I did, I'm just going to go over some quick slides real quick, and then we'll have time for questions. It's called OMSCS for those of you who don't know. It's at Georgia Tech, and it stands for Online Master of Science in Computer Science. One thing I wanted to mention that was, I think, pretty common criticism of any degree is that it is not a software engineering degree. They're not going to teach you how to become a good software engineer if you want to go and work in software engineering. They teach you computer science, which is foundational, but it's like saying just knowing math doesn't make you a good engineer. There's a lot that goes into being like a mechanical engineer, a chemical engineer. It's the same thing. Knowing computer science is definitely really useful, and you can't really get around some of these concepts because, especially as like the cloud explodes and things like that, having knowledge about like what a computer is actually capable of and what it does and what the hardware limitations are, and like whether or not IO is going to be your bottleneck versus compute versus memory access, like those kinds of things are definitely good to have in the back of your mind. But they have a pretty limited amount of classes that teach you like how to use Git and GitHub. That's pretty important, or version control in general. It's pretty easy to pick up on your own, or how to, write a design document, or how to perform a code review, or like how enterprise software engineering works. Like, what is a big company with thousands of customers, or $1 billion company? How do they run their software portion of their business division? It doesn't really go into any of that. So sometimes that could be surprising. Some of you are probably like, oh, no shit. But there's just something to keep in mind, is that you're learning computer science at this place and not necessarily software engineering. I think the best place to learn software engineering is to just, open source contributions can be pretty daunting. But those are good places to learn just kind of how like typical interactions go between a bunch of people that are trying to accomplish a common goal, which is what a software engineering team is doing. And you get exposure on reading other people's code, such and such. So, or you could just, try to write your own, try to do something, and then get a friend to work with you on it. It doesn't have to be something that'll make you guys money. It can be anything, any problem that you guys want. And just trying to like coming up with new problems that no one's ever really solved before will force you to interact in ways with the code and with your processes that will kind of help you get more familiar with what it's like to be a real software engineer. For those of you that are thinking about doing it, I think a lot of you guys probably are. I think Foothill is actually a really big feeder school, so to speak, into OMSCS. The price is still less than $10,000 from start to finish. I think I ended up paying around $7,000 or $8,000. It's like $600 a class, basically. I took 1 to 2 courses a semester. You can take more if you petition, but it is designed to be a part-time degree. So 2, like by default, is the maximum that you can take. I would recommend not doing that. I did it one semester and it sucked. I never saw my girlfriend. I never saw my friends. I was working like 60 hours a week on top of my job. So they can get really demanding. Some classes, on the other hand, are really easy. And so like you can kind of space it out where you maybe take one hard class and then one easy class to kind of give yourself a breather. Some of those take like 5 hours a week. I mean, it all depends on your background, but some of them don't really demand a lot from you. Some of them are very, very demanding. In terms of what I did, it's probably a lot like Canvas. In fact, we use Canvas. They have like, excuse me, online content delivery, so lecture videos. Sometimes there's textbooks, but it's pretty rare that, in fact, I don't think I ever had a class that required a textbook, although they did give you useful textbooks to go. I mean, the professor's not here, so if you guys have ever heard of like Z Library or Booksy or anything like that, you can find PDFs online. Don't tell anybody that. I definitely didn't do that. Wink, wink. There's coding projects, which I think was really valuable, just because they'll teach you a bunch of stuff like how to use virtual machines and stuff like that. But some of them are really simple, like implement a function. Some of them, like over the course of the semester, are iterative, so you're building to the same goal. And then other ones are just standalone. I can go into some examples of ones that I did, but I found them all pretty useful, actually, if not just to practice with Python or C++ or Java. And then there's exams. The exams can usually be, or are usually delivered on Canvas, and can involve free response questions or short answers. And then my least favorite, which is multiple choice. There's no thesis that you have to do, but there is a way to get someone to sponsor you as a graduate student that you can do research for them and turn it into a thesis. It is really rare. They don't discourage it or anything. It's just the fact of the matter is it's really hard to find a faculty member that is willing to take on a distant graduate student, like a satellite graduate student. But if it is something that you guys are interested in, there are people that have gone to MSCS and then continued in academia to go get a PhD because of the research that they did as a grad student at MSCS. But for those of you who are just looking to get like a terminal master's degree or professional master's degree, you don't need to do a thesis. It's all course-based. And the really cool thing about OMSCS over competitors like UT Austin and even University of Chicago, like at Urbana-Champaign, I think has an online one, is that there's no distinction between the online and the on-campus master's degree. It is a Master of Science degree. It's not a Master of Computer Science. It's a Master of Science in Computer Science. So if that matters to you, that's what this degree is. And then when you get your diploma, it's indistinguishable, and for good reason, because it's the parity between the on and off-campus courses are like 1-to-1. It's in theory supposed to be the exact same material. The exact same material is tested. You get the same projects. So the nice thing is that, and if some of you guys are worried about, like, I think online degrees have kind of become less suspect as the years have gone on. I know I'm 29. There was this whole like for-profit schools that did online stuff, and so anyone who had an online degree kind of got looked at sideways. But now I think this degree is changing that. But anyways, if you guys are worried about like, oh, will anyone know that I went to an online school or anything like that, your diploma doesn't say anything about it. Georgia Tech doesn't keep that as a record, really. So if nobody asks and you don't want anyone to know, your diploma won't say anything about it either. So I thought that was kind of interesting. I personally don't care, and in my experience, I haven't found anyone who does care that I've interacted with directly. So take with that as you will. If you're interested in the courses that I took, I just took a quick screenshot of my transcript. There's 10 courses that you need to take. You need 30 credit hours, and each course is worth 3 credit hours. So you just need to take 10. All the courses, except for some random like seminar courses, are 3. So basically you can just pick what courses you want. And there are several different specializations. I don't know off the top of my head. I can look it up, or if you just Google OMSCS, their like landing page goes into it. But I took an algorithms class, which is more or less kind of like a complexity theory and an elite code class in disguise, computer networks, computer architecture, information security, 2 operating systems classes, software architecture and design class, 2 AI classes, and a machine learning class to kind of round myself out. Some of the coding languages that we use / technologies that we used were, a majority of the program is either going to be in Python or C and C++. You do, like, for instance, in information security, we had to write a tiny bit of PHP. I didn't know any of these going in. The game AI class, I did C# because we work with Unity and you just make like a video game. Some of the classes require some Java. And I think one thing that's actually kind of useful that I didn't expect to get out of this was like learning how to use Azure or AWS, which are cloud offerings, and virtual machines, which can be pretty nifty tools if you guys don't know what those are. Like if you guys have a Mac or a PC at home, you're probably running Windows or whatever OS X is on. That's an operating system, and typically you think about one operating system running on one physical piece of machinery, like one motherboard, one CPU, a couple sticks of RAM or whatever. Virtual machines kind of take that and let you run like multiple operating systems on the same hardware. So like at Azure, they can have one server that's basically a really strong computer, and it gives the appearance that 100 people have their own personal computer on there. So you can use that like to, one benefit of that is that you can like log in from anywhere, and Azure is where your computer lives more or less, and you can write code on your local machine. But if it's like really crazy, let's say you're doing like LLM or computer vision or something that requires a lot of computing power, you don't want to go out and buy a $40,000 workstation. Azure already has those, and you can pay $12 a month or something as a student to have access to it. And it doesn't matter if you're taking a vacation in Mexico or Las Vegas or wherever you are, you can just log into your Azure machine and it looks like it's a computer that you have at home. So that's pretty useful in terms of what actually goes on in like software companies. A lot of them will purchase cloud infrastructure and offload a lot of that compute to the cloud infrastructure. So knowing how to kind of log into Azure and provision a virtual machine and like pick which one is the best, the cheapest for you and stuff like that can be a pretty valuable skill. And like I said, I wasn't expecting to learn that going in. I didn't even know that that was something that we did. But now after everything is said and done, I use it a lot. Some general thoughts that I had was A, was I prepared going in? And B, how much did this Foothill series of courses prepare me? I think that I had a pretty strong background in math from my physics degree, and it's hard for me because I feel like I'm biased. It's hard for someone who's been doing this for a while to remember what it's like to not have that knowledge. I think, in my opinion, that the math required in the program is nothing too crazy. I never had to do any calculus really. There's some linear algebra, but again, in my opinion, from what I remember having to learn back when I was first learning calculus and linear algebra, it should be stuff that's just barely a couple steps above like algebra 2. So if some of you are thinking about going into this program and you're worried about your math background, the math required in the courses that I took was nothing too crazy at all. It only came up maybe in the complexity theory class and then some of the artificial intelligence stuff. Other than that, it's just a lot of just coding. There was no like solve this integral or do this crazy proof in linear algebra or anything like that. I think that this class is definitely useful in terms of just how do you use like an IDE. I don't know if you guys are using Visual Studio or VS Code or anything like that, or Client like CLion or anything. So those kinds of skills that you wouldn't think, oh, I could just pick it up. Some of those, like working with C and getting it to compile and debugging memory errors and stuff like that, doing it now when you have the time is that much, make you that much more efficient when you go into the program, because you won't have to spend 2 days figuring out why you're getting a memory error when a project is due in a week. You get those 2 days back because you do it now in this class, so to speak. So yeah, I think if you're like that, the question is, am I wasting my time taking this class? I don't think so. I think that I was prepared. In fact, one of the classes that I took, an operating systems class, was heavy in C and C++, and Anand's class was the only real exposure I had into C++ before that class, and I still got an A. And you do some pretty crazy projects in that class. So I think that if you put in the work now and you just like spend time getting familiar with their material, and you're not afraid to make those mistakes and like crash your program and crash your computer and stuff, those lessons that you learn will make you that much more effective when you actually go into the program. My knowledge coming in, like I said, we kind of did some MATLAB, which is like a scripting language, and I knew more or less like, okay, here's how a program kind of works when I run it. Other than that, my computer science knowledge is like pretty much zero. And I got all A's in all my classes. I only have one B, and that's because I got really sick with COVID during an exam in my opinion. That's my excuse. So I had one bad exam that I couldn't drop, so I got to be in that class. But success is possible even if you don't have like an undergrad degree in CS or anything like that. Part of that, I think, is, like I said, getting good at picking up gaps in your knowledge and then actually going out and shoring up those gaps. It can be exhausting. It sucks sometimes and it's tedious. So if you know, like deep down, that's not something that you like doing, or you don't think that you'll be able to do that over a period of 2 or 3 years, and you know that your background isn't that strong right now, then maybe I would say spend a little bit of time when the pressure is a lot lower, picking up those skills much slower, because like the workload can be pretty crazy, which goes into my next point. You have free time, you have time to spend like with your significant other or your partner, and then you have time for school, and you can really only pick 2 out of the 3 at any given point, unless you have really easy courses. It's been quite the journey. I haven't seen a lot of my friends in quite some time. On average, I probably think I work an additional 30 hours a week, just catching up on lectures, getting familiar with material, finishing projects, studying for exams. And it's been that way for like 2.5 years. So it's a long time to spend having like, I'm excited to see, like, I've forgotten what it's like to clock off at 5 p.m. from work and then just be like, what do I want to do? Like log on to Steam or like go to the gym or go on a walk. So you get really good at time management, or you just get totally burned out. I think that's one of the biggest things that I would say about this program is that do not underestimate the workload unless you know for a fact that you're like a super genius or you already have like 2 degrees or something like that. It can be pretty gnarly sometimes. If you have a significant other or family members, definitely talk to them going in. See how they feel about you being part of this program and what that, like, if that is the case for you, have a plan. I set up scheduled date nights with my partner because it was just that hard to like find free time. There was no free time, so I had to make free time. That worked for me. Again, this just goes back to that point, like don't underestimate the amount of time that you probably are going to have to spend to succeed in this program. At least if you want to get like A's. If it doesn't matter to you, I think that getting a B, probably you could knock maybe 20 or 30% of that effort off. But in my opinion, if you're paying to go to a master's degree and it's something that you want to do, you should do it to the best of your ability, because otherwise why do it? You know, unless you just want a rubber stamp and you think that that'll help with like career prospects, which it may. I think that I'm not going to tell anyone that they're going to do this for the wrong reasons. That was my philosophy going in, is like, I'm paying out of pocket for this, so I really want to get as many A's as I can. There are a lot of international students that do OMSCS. English is my first language. I'm a US citizen, so even then, some of the classes have more of a writing requirement. You'll be writing reports if you choose to go that route. And certainly being able to understand and deduce like unclear instructions, project instructions, test prompts, question prompts. I've noticed some of the international students, which I think is actually unfair to them. I think that the program should try harder to make things really clear. Will lose points because their grasp of the English language isn't as strong as like a native speaker, and they misunderstand something about a problem statement, or the problem statement is very vague. So if any of you do speak English as a second or third language, I would be prepared for that. They tend to be really forgiving if that tends to be the issue. You go up to them and you say, hey, you know what, English is my second language and I read the problem this way, or I haven't learned this word or something like that. And I think that when you're writing answers to test questions, for example, they tend to be pretty forgiving if they understand that English is your second or third language too, if you're not using like, as long as you're close enough. But I will say the reason why I wanted to bring this up is there's been like a non-zero number of issues that I've seen arise due to difficulties in understanding the written word. So if that is something that applies to you, keep that in mind, and just be honest with yourself about like what your proficiency level is with English specifically. Most useful skill, I think I talked about that, was being able to learn, pick up things on my own. Learning is a skill like anything else. The more that you force yourself to find like an uncomfortable situation and be frustrated that you don't know something and spend hours Googling it or reading a textbook, will make you better at it, and you'll spend less time doing it over time. But it is something that you should strive to do constantly if you want to be like a lifelong learner. Why I did it was because I was interested in it, and I wanted to hopefully make more money than I was making at Lockheed by like getting hired at Amazon. It worked for a little bit, and then I got laid off, So currently right now, I guess it kind of helped. There's still jobs that I'm applying to and getting interviews for. So I think, like I said, the unfortunate reality of the situation is like someone with, especially right now in the market, someone with a resume that has a computer science degree on it is probably going to get picked over someone who doesn't have a computer science degree, whether a bachelor's or a master's. Like I said, I don't think that it has anything to do with anyone's actual ability. I've met people who don't have degrees at all that are really good programmers, and I've met people with 2 degrees that I know more than at the current moment in time. So I don't think that like you yourself should see it as a reflection of your value, but especially right now, I think that it would be wise if I really wanted to get a job in software engineering to get some sort of degree, and this is one way to do it, especially if you're pivoting careers. And another thing is a community and the network that you build up just from interacting with the students. Slack is probably like where the most casual communication happens. There's a Slack workspace for all the students, like totally. So you can just kind of go through all these different channels and like meet people if you guys are familiar with Slack. There are some like official, unofficial Discord channels. People always branch off and start their own study groups on Discord. But I've gotten referrals. I've made friends. I live in the San Francisco Bay Area, so I've made friends that I hang out with through this program. And so I think if you're looking for a professional network, there's guys that have been software engineers for 20 or 30 years in the program. There's people that are mechanical engineers in the program. There's project managers. Like anyone that you could think that has any kind of qualitative bent to them is probably going to have some sort of representation in this program. And it can be valuable to meet and interact with those people, if not just because you all share a common interest, and it can just be kind of cool to hang out. I think that's my last slide. So that was kind of my little spiel on OMSCS. If anyone has like specific questions, I'm happy to talk about it, or if I think of anything else, I'll let you guys know.
I was wondering about if what your relationship is with maybe professors from the program and like interacting with them and getting like if you needed like a reference letter or anything. Like have you been able to build a relationship with one or two of them where we're kind of like, friends or whatever, or like you can like email them and they'll get back to you and they'll be like, yeah, Fred, I know who you are and no problem, I'll get this done or something, or is it not really like that?
It is difficult for it to be like that. And I think I have my own opinions about kind of whether or not professors deserve recognition for teaching online classes. In the most recent class that I've taken, I've met the professor for 30 seconds over Zoom, where he just showed up and basically said good luck on the exam. I don't know what he does. He hadn't created like his own lecture videos. He used the previous professor's lecture videos, which are really good. But a lot of the professors just kind of have their name as they need someone to be in charge of the course, I guess. The converse of that is that the TAs, there's a lot of TAs that were past students. Like 90% of them were past students that go on to be TAs in the class, and you do interact with them a lot. I do have relationships with a lot of my TAs because I spent a lot of time with them in office hours or emailing. There are some professors that do make a significant effort to host their own office hours and make themselves available to students. But out of the 10 classes that I've taken, that's probably been maybe 3 of them. So it really just depends on like the professor. And I think sadly, especially at a place like Georgia Tech, no one's going to get hired for their teaching ability. Like a professor, someone with a PhD is going to get hired because they are involved in an area of research that Georgia Tech wants to be at the forefront of. So they're not getting hired for their teaching ability, which kind of means that most of them aren't good teachers and really do the bare minimum to teach. But the course material and then the TAs is not really something that the professors have refined, like created themselves. And so I think that I don't want to give you the impression that like the material is crap or anything like that. It's just that the professors aren't really involved and it takes a little more effort to get to know them, but the TAs can get really involved. I think if you're trying to parlay this into like a PhD program, probably a letter of recommendation from a professor would be better than from a TA. But if you were going to use this to go to grad school and get a PhD, you probably should be working with the professor anyways on our research projects, in which case you would get that level of familiarity, if that makes sense. Like professional letters of reference, I don't think it would matter much if it was a TA versus a professor, and definitely you could get those kinds of things from TAs. They will get to know you very well. I don't know if I have like I don't know if anyone would like invite me to their wedding, so to speak, but I spent a pretty significant amount of time with all of them and would get to know, like they would get to know my face and stuff like that. Does that answer your question?
Yeah, thank you.
Yeah.
Hi,
What
Fred.
else?
I had two questions for you.
Sure.
One, I don't know if you touched upon this, but if you could talk a little bit about the application process. I'm currently switching careers, so I don't know how the application process necessarily works for like a computer science master's. I guess in specifically, I do know that they're probably looking for, I think it's like a GRE or a GMAT exam, if I'm correct. I don't know if that applies to this
Mhm.
particular school. And then the second thing is, I do remember you mentioned that you personally didn't have too much of like a traditional computer science background, and I've read in various sources like it's important to demonstrate that, you kind of want to do this and you want to maybe show like a couple projects or something like that, or like a portfolio. So yeah, if you could talk a little bit about that.
Yeah, definitely. A disclaimer is I don't know what the application process is like today as of 2024. So when I did it in 2021, I'll tell you exactly what I did. I submitted my transcripts from undergrad, which clearly listed kind of what math classes I had taken, as well as some of my AP scores, just to show that I had actually, like the reason why I didn't take calculus in college is because I'd already taken it in high school. So they didn't think I hadn't taken calculus. Because at the time I had read that like showing a background in calc and linear algebra, I didn't have anything in discrete math. If you ever see that, I had no discrete math classes, but I did have linear algebra and calculus and mentioned that. I had no portfolio or projects that I submitted. I did submit my transcript from Foothill after I'd finished all three classes. And then I think when I applied, you had to submit a letter of intent, which is just a short personal statement about like why you want to do the program. Mine was nothing special, like some people have, really inspiring stories or anything. I was basically like, I'm doing this at work. I think it would help me professionally, and I think it's interesting. With a little bit nicer verbiage. I spent a little bit of time on it, but it was nothing crazy. You don't have to have like a sob story or anything. And then you have to have, I think for me, it was 3 letters of reference. And the more closer that you can get to someone who's directly worked with you or assessed your work, particularly in a computer science realm, so code that you've written, or if it's not code, maybe something technical that you've done, a project, because they're looking for like kind of quantitative. You have to be good and have like an analytical mind in order to succeed in this program, I think. So any kind of work that would speak to that, maybe it's like you broke down requirements on a project and your project manager was working in lockstep with you. They could speak to your ability to like take something complex and then break it down into small steps and execute. If you have written code, great, get a fellow coworker that's like done code reviews with you to submit something. I didn't get to see anything that people wrote about me, so I don't know if they were all 3 of them were good or if someone wrote something bad about me, but I got in. So I had 2 coworkers and a past professor write a letter for me. I think the breakdown, they don't really care who does it, as long as it's actually someone who knows what they're talking about. It can like speak intelligently about how they feel you'd fare in the program. Yeah, transcripts, like a small essay that was maybe like, I don't know, 500 words, and then 3 letters of recommendation that I'd sent out. So if they're still doing the letter of recommendation, one thing that I wish that I had done sooner was talk to those people and give them more time to do it. Just because out of respect, if they're going to be writing it, you don't want to be like, hey, can you write me a letter of recommendation? By the way, I need it by tomorrow at 5. You're probably not going to get a super good one. So if you're thinking about that, identify like what semester. I think they will admit in both, like I started in the spring, which is I guess a little bit different than when you think about starting school. I started in January. Most people start in August or September. So there's like a rolling application. If you miss it the next one, then there's one that's going to happen not too much later in the future. So but yeah, basically the long or the short is just identify people if they still need letters of recommendation sooner rather than later. And I think that they will kind of tell you like a skeleton of what makes a letter of recommendation good versus bad. So I just kind of gave them that guidance from Georgia Tech specifically about what they were looking for. And then another thing that I did that I think helped was I wrote my own letter of recommendation for myself so that they had more examples to draw from. Then I don't think any of them just submitted my own letter of recommendation that I wrote myself, but just like help them help you. And then I think that helped a lot of them write me a strong letter of recommendation. It was like, here's all the things that I hope that you say about me. At the end of the day, you can say whatever you want, but this is the kind of stuff that I think Georgia Tech is looking for, and here's how I think I meet those desired qualifications. Does that answer your question?
Yeah, just one thing real quick. If we could contact you in the future with questions that maybe we didn't remember right now, is there a way to do that?
Yeah, I will. I wonder what the easiest way to do that is. I could put my email on another slide, or I can send Anand an email, and then I don't know if he could distribute it to you guys if you want. Maybe I'll do this. I stole these slides from this person. That's not me. Let me go ahead and do this. Live typing. You guys see that?
Yes, we can.
Okay, yeah, so 2 F's, 2 N's at gmail.com. But if you don't want to copy this down right now, I'll tell you what, I'll also send Anand an email and let him know that you feel free to contact me. And maybe I'll put my LinkedIn in there too if you guys want. So let's see, where does Zoom go? Okay, here we are. What else? How long does this lecture usually go for? Like, what time does the class usually end?
We're like 20 minutes over already, but
Oh, really?
yeah. And normally it's like 6 to 8.
6 to 8?
Yeah.
Yeah, I'm happy to stay on if people have specific questions. Let me look at the chat.
I mean, this is completely unrelated, but are you a Counter-Strike player?
No, I don't play CS.
You don't play
My
CS?
friends have been trying to get me into CS. My reflexes aren't good enough. I don't have I need a CRT monitor if I want to play CS like
You want a
seriously.
CRT? Okay.
You know. No, I'm more just like Master Chief Collection or Deep Rock Galactic and stuff like that. I'll hop on Steam. Yeah, if anyone wants to add me on Steam, maybe I'll put my Steam username too.
So I got a quick question. And it may be a little bit of a silly one, but I know Professor, and he has a very interesting mentality of thinking that, AI is kind of like the thing that's gonna, prevent people from getting jobs in software engineering, and that's kind of I think he said it was like kind of useless to study software engineering and to get a job and stuff like that. I guess like, what would be your opinion on that whole idea?
I think my opinion, and that's what it is with a capital O. I don't know what the hell I'm talking about, even though I have a master's degree. I think AI in the future will be disruptive. I think in some sense it has already disrupted the industry, but I don't think at the current day that it is because AI actually has the ability to replace software engineers, for instance. I think that writing code and writing simple code can be done with clever prompt engineering with ChatGPT or Claude or Gemini. And I think that that is actually a good thing for software engineers because it makes them more productive. I would be very surprised to see a complete system that companies can buy in which you would not need to have software engineers in the loop, because engineering is so much more than writing code. And if you look at like Devin just came out, everyone was freaking out about Devin AI, and it was BS. Like, it's still not what's going on. It was not able to solve customer requirements. It's not able to work. It can't read a Figma doc, if you guys have ever heard of Figma, and translate those into front-end requirements. Or it can't troubleshoot a complete like distributed system. Like at AWS, the code base is like probably actually, millions, tens of millions of lines of code. And like Copilot, if I'm working on a personal project or whatever, starts to forget what I'm doing after like 3 files worth of input. So I don't think that we're there yet. From what I understand about hardware, the cost of scaling is like ChatGPT 2 to 3. Let's say you add an order of magnitude or 100 times more parameters to train your AI on, then maybe you will get like a 5x benefit or a 100x benefit in terms of how well it's able to perform. And that's actually even its own thing that we could spend hours talking about, is how do you measure how well, what does it mean for an AI to do something well? What is that metric? That's already kind of a hard question to answer if you really try to quantify it. But I think, GPT-5, for example, when that comes out, in order to get more performance out of what they've already done with their models, they're going to have to train it on 100 times more parameters, and they may only get like a 1.2 or 1.5x in performance increase. And the next iteration is you're going to like this diminishing returns. There's an S curve. If you think about like, there's going to be a point where everyone is hype on AI and it looks like it's advancing really, 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 really fast. Eventually you're gonna have to pay the piper, and like it's not going to do that forever. It's not just going to be an exponential curve. And I mean, it's like, I don't know if any of you guys are investing or into investing. Like one example is like, oh, like buying treasuries is usually really safe because if the United States government can't pay you back on your treasuries, there's probably much worse things going on. Like that implies that like the United States has collapsed or something like that. So you're probably not going to be worrying about money at that point. You're going to be worrying about like there's nuclear war or something. I think that in much the same way, when software engineers really have to start worrying about whether or not AI is going to make them useless, every white collar job is also going to have that same problem. You're not going to have lawyers anymore. You're not going to have accountants anymore. You're not going to have actuaries anymore. And I think at that point, like, I'm not going to say that that's impossible. Maybe it will happen. It probably will happen in the future, depending on like how smart people are that work on this stuff. But I don't think it's worth worrying about now, because if it ever gets to that point, we're going to be one of tens of millions of people that are suddenly going to have to find something else to do. And I don't really know what's going to be safe at that point. If you're really like keeps you up at night, my personal take is I think that robotics is a lot further behind on stuff that could be performed on a computer. So I know everyone's talking about the trades. It's kind of tongue in cheek, but do something that requires navigating complex terrain, or go be a diver or an underwater welder, because I don't know if that's going to be as in danger. But I think eventually, one day, it might happen. But I am not as convinced as other people that it's like a tomorrow thing. Like today's generation of students shouldn't stop studying. If the only reason they have to stop studying is that there may or may not be a job for them in 2 years or 3 years or 4 years. I don't think that we're there yet. And if it is, then you guys are free to come find me and tar and feather me. I'll take responsibility for that. But like, have any of you guys ever used ChatGPT or Claude or anything like that? Sometimes it's garbage. And these are like the state-of-the-art models. And from what I understand about like what it actually takes, like Microsoft just invested $100 billion into building a new supercompute center to train more AI. And like, that's the scale that we're talking about now, is like, yes, these companies have lots of money, but they don't have infinite amount of money. And GPUs, which are used to train these models, can only get so much more powerful. Like we're starting to reach the quantum limits of like how small we can make transistors. So that's like, there's all these performance benefits are going to get smaller and smaller and smaller, because like we're kind of there's no more room to grow in these like specific parameter spaces. You can't make transistors any smaller. Electricity is going to become like prohibitively expensive, or you're going to have to start putting like billions and billions and billions of dollars to start seeing more improvements, and eventually something's going to give. And like I said, to summarize, I think that AI has the potential to like revolutionize how we work by making us more productive. But I wouldn't say I share the same fears that like I'm going to be out of a job forever because some guy hired a computer to do the work for me. That's my long-winded take on it.
Thank you.
I will say, don't fall into the trap on that of learn how to use ChatGPT and Claude and stuff like that responsibly. It was not around when I was a student. I'm not stupid. I know sometimes it's 2 in the morning and you're trying to finish an assignment, and it seems easier that maybe Claude or ChatGPT could do something. Whether or not you want to cheat or whatever, or whether or not you want to do that, that's on you. But I would say that in the long run, try to invest the time. Like, don't let that become part of your brain, and don't offload all that mental processing and learning onto ChatGPT just because it's quick. Try to resist the temptation and spend some time doing things more slowly and struggling with them, because foundationally, I think that you'll learn more. That being said, if you're like working with a new framework or trying to like understand what a function does, I think a responsible use of ChatGPT is like to give you a quick 5-second rundown so that you kind of know where to look. I think that I see a lot of that. Like, you don't want to be the guy that doesn't know how to code after 2 years and agree because you just like fed all your projects to ChatGPT, you know? That is a very real thing that I've seen people do, and it can be you if you're not careful and deliberate about like forcing yourself to do something more uncomfortable now, which is like, man, I suck at coding, but I'm going to still try to write code. That's my word of caution, I guess, is don't fall into that trap of just like doing everything on ChatGPT, even if it is really good. But use it as a tool to accelerate your learning, I guess is what I'm trying to say. And then on that, in general, like I said, I think like the most beneficial thing I got from this program was learning how to learn. Try to spend some time into learning how you personally learn the best. There's a lot of research out there about like how to learn effectively. Cramming is not one of them, although sometimes it's a necessary fact of life. But like spaced repetition, like if you guys are practicing leak code, do a bunch of different leak code problems. And like one tool that I use, I can email him this too, is called Obsidian. It's just like a markdown notepad basically, but there's lots of plugins for it. And they have something called spaced repetition. And studies show that if you do something once and you never come back to it again, your ability to perform that action or utilize that knowledge drops off very quickly over time. That's just how it works. Like the less you use something, the more quicker that you lose it. But if you do something and then in 3 months or 4 weeks you do it again, then the rate at which you forget becomes lesser, and so you're able to recall things for longer, and that stacks the more that you do this spaced repetition. And so like if you're going to be doing leak code, for example, like whether or not it's actually a good indicator of how good of a software engineer you are. I got asked a leak code question today in an interview. And so like some of that is just you need to do enough leak code to know, like to have seen that problem before. Like spaced repetition can come in handy there. And there's plugins out there that will like you just log what leak code problem you did and you tell it to remind you in 3 weeks to do that same problem again. And then you can just do that for like 50 problems or whatever, like stuff like that. Like go out there and learn like, okay, like spaced repetition or coming up with your own test questions, like just thinking like what are the kinds of things that they might ask me is actually a really, really good way to learn. And studies have shown that students are like 90% accurate, like on the mark in terms of like what questions will actually be asked. So stuff like that, especially if you're going to go in the master's program, is really worth being good at. And it just helps like your brain just becomes more malleable over time. You just get like a sponge, you just absorb more stuff. So never stop learning. Don't be afraid of failing and doing the hard stuff. And then have fun when you're doing it. You know, at the end of the day, if this sucks and you don't like it, no one says you have to. And I would say life's too short. But if you do like it, then don't shortchange yourself and go all in. That's my final take.
I had one last question since you were talking about tests.
Yeah.
Is the program, do they tend to have like open book exams, or are they pretty big on like learn all these things by heart, and then the test is actually we're testing how much you can memorize this thing that you just learned about?
I would say there's a couple parts to that question. I'll try not to be so long-winded about this. I've had open book tests. I've had open internet tests. And I've even had a class in which he released 80% of the test questions, and we were allowed to discuss them during the test period. So it was just basically like a huge group project, and that was the exam. I've also had tests where they were closed notes, closed internet, probably like you would see on Canvas. They use something called honor lock, which basically you have to like, you can only use one monitor and it tracks you. It's pretty invasive, actually. It's a huge pain in the butt, but closed notes, no note, like self-taken notes or anything, no crib sheet or cheat sheet or whatever you want to call it. So I've had it all across the board. What I haven't really had a ton of is like pure rote memorization of concepts. Every test, or most of them at least, will try to be application, like knowledge application based. So it'll be something that you haven't really seen before, but you should be able to intuit or reason through based on the concepts that you've learned. It's like not a lot of trivia, I guess is what I'm trying to say. But yeah, I've had classes where you can have 5 sheets of notes. I've had classes where you could have 1 sheet of notes. Like I said, I had a class where you just said, here's good luck. These questions are so hard, you're not going to find them on the internet anyway. So go ahead and use the internet. That was an artificial intelligence. So yeah, Does that answer your question?
Yeah, thank you.
Yeah. Oh, yeah. I'm trying to think if there's anything else.
I have a
Yeah.
question. So I'm switching from data science to CS, and I'm noticing that the personal portfolio is pretty emphasized in this field. What kind of personal projects have you done, and how did you find the time to balance personal projects between school, work, and life?
So I will say personal projects haven't been a huge part of what I've been doing. I have some super long lead ones. Like right now, I'm very at the beginning of learning how to implement like a Game Boy Advance emulator in Rust, but that's because I want to learn Rust. So I think if you're going to do a personal project, um, for the purposes of like, are you talking about like to get put on your resume basically to make you a more attractive candidate?
Yeah, that, but also for personal gain. Both,
Yeah.
maybe.
So for personal gain, I would say um, to use your Google foo. You know, I think there's especially now like the nice thing about being a software engineer is that by virtue of the profession, you're on a computer, which means that a lot of software engineers tend to talk to each other on the internet, and there's tons of tutorials and resources out there. So if you want to learn Django or something like that, or you want to learn front end development, just go like do one of those mass market tutorials just because they're actually like at the end of the day, you should probably learn how to do some of that stuff. So if you find a project out there that looks interesting but simple, and it's like your first exposure to a given technology stack, I would say just do it. And in fact, that's probably the biggest piece of advice that I could give you in general for personal projects is to like, at a certain point, you're gonna have to just go execute. So just go do something. It doesn't have to be something crazy. Just go do something. And if it's for learning, it can be something that everyone else is doing. If you want to get hired, from in my opinion, from both what I've heard and having been on the other side of the hiring table, if it's the same tutorial that like you got to keep in mind there's a lot of people out there that do computer science. If I've seen that project on a resume more than like 12 times, then that's an indicator to me that like it's not as useful as a data point to evaluate you as a candidate because it's more of a question mark. You could be really good, but if 12 people have done the exact same like Sudoku solver, how do I know that you just didn't go look at somebody else's GitHub and copy the code? And if you did do that, how do I gauge how well you actually understood what you were doing versus did you just copy and paste it to put it on your resume? So if you want to do something that's worth going on a resume, there is no criteria for like, I mean, if it makes money and you know you have like 1,000 or 1,000,000 App Store downloads, that's a good thing. It doesn't have to be that way. If it shows that you're trying to solve a problem or explore a problem that you yourself are interested in, it doesn't matter at all like what the arena is. There's people who have done like sports betting stuff. There's one guy who did like a bot to train like computer vision on CS or something like that, which is what I read about online. I've seen people that just do like for data science, there's a lot of visualization and ingest projects. So it could be any, and that's unfortunately kind of frustrating to hear is like, oh, you can do anything. But I really think that the most value that you're going to get out of it and that the most value it's going to have towards your career, if you're going that route, will be coming out of something that you yourself are interested in because A, it's going to be novel and no one's going to see it before. So they're going to have lots of questions that you can then talk intelligently about because you're building it. And B, you're probably going to stick with it for longer because it's something that you're curious about as opposed to forcing yourself how to build like a LinkedIn clone to learn React or something. Like, who cares? It's probably good to know, but it's like not cool. I built LinkedIn, it already exists. You know what I mean? So, um, that's my advice in terms of what I've done. The master's program has sort of served as a proxy of take-home projects, and I've been lucky enough where some of the projects were like advanced enough that they're worth talking about on a resume. One of them was building like a distributed file system server in C++ and using something called gRPC, which is like remote procedure calls. So it was using multi-threads, client server model you could like upload, and it's like basically Dropbox. Another one was a virtual machine CPU and memory coordinator. So like as real workloads are running on several different virtual machines, the computer only has like, let's say 4 cores on a processor, and a core is where the bulk of the computing is done, like a CPU basically. But you have 8 virtual machines, you have more virtual machines than you have cores, so they have to share cores with each other. but maybe this virtual machine is doing something really crazy and this guy's doing something really crazy. If you try to put them on the same core, performance is going to suffer because they both want a lot of computing activity from the core. They need a lot of computing cycles, and there's just not enough available for both of them. So what if I move this guy to another core? So that, like, there's a lot of, basically what makes a good technical project is how well you understood the technology and like how you can, what interesting problem did you solve or problems have you come across in doing that? That's really what interviewers are looking for. And as a learner, I would say the criteria, like I was saying, is much less. Just go find something that you either feel like you want to learn or that you should be learning, and then just go do it. Don't like look for the best React project out there, or don't look for like the hard. Just as soon as you find something that you're like maybe feel like you'd be 50% interested in, just do it for a week. And that's, just like get it done, because you'll spend forever trying to like hyper optimize. Okay, like what's the best technology I should learn? Don't fall into that trap. Just go do stuff. That's my biggest takeaway, is just go do something today or tomorrow. It doesn't matter what it is. Just start doing something.
Got it. Thank you.
Yeah. That was another long-winded one. Leak code, like I was saying, is worth it still if you want to talk about career stuff. I haven't tried Code Wars or Code Forces. Code Wars. Code Forces is like an evaluation site, I think, but that seems pretty cool. Try to write the best code that you can on Leak code and like understand. Choose a language. I do Python for interviews, and go deep on the language. I think Anand said something at the beginning of when I got here, which is like you should go for depth over breadth. I think today that's starting to become more true. You become more valuable as a subject matter expert. So start trying to do that now and just like strive to understand something very deeply. Understand a lot of things, but pick one or two things that interest you to understand deeply. I think that would be my advice for people that are like looking to start careers in this arena. There's a lot that you can do out there. I don't even know half of it myself, but I know that there's a lot. So there's probably something for everybody out there. I think that's mostly what I had to say. What did I say I was going to do? I was going to give him my email. I'll give him my LinkedIn. I'll give him my Steam ID. If anyone really wants to add me, we could play Halo or something. I guess I'll ask one last time, anything else that you guys want to ask at all about anything?
Yeah, I kind of got, I guess, two questions. One of them being any classes, I guess, from GA Tech that you specifically recommend that comes to mind. And then as somebody that kind of doesn't have too strong of a math background, I transferred over from like accounting kind of thing after I got that degree, but I only have like Calc 1 on my belt at the moment. I guess, would you definitely recommend trying to pursue like Calc 2 and then like linear algebra and everything like that to kind of get a better foundation?
It's a good question. I'm going to answer your first question about classes first. I think I pulled it up if you guys can see my screen. Where is it? Graduate Intro to Operating Systems is a great class. I would even say it's a great first class. It is the perfect level of difficulty, I found. Like you'll feel challenged, but you won't feel like swamped. And you learn a ton about operating systems, and the projects are really good. That's where I built that distributed file server. So you learn multi-threading, you learn about shared memory, and the lecture quality is really good. The professor actually gives a shit, and the TAs are pretty knowledgeable. So overall, that's a great class to go into because the entire infrastructure, the teaching infrastructure built around it, is strong. There's lots of support and resources out there, and you'll just feel better about yourself having completed that class, because it is one of the more difficult ones, I think. If you really like that class, I also enjoyed Advanced Operating Systems, which takes more of like a historical look at operating systems and kind of goes into some more advanced projects. A really fun one that I enjoyed was Game AI. Artificial intelligence, where you just kind of build like little dummy projects in Unity. So that could be like a good breather class where it's fun to log on every week and like see what the lecture is about. And the projects are actually fun to both build and play, because you can like test out your artificial agent that you built or whatever. You like build a racing game where the car drives by itself on a randomly generated track. and you get more points in the course depending on how long your car stays on the track, or you program like minions from Despicable Me. I don't know why they're in the class, but you program them to play dodgeball with each other, and you get more points if you get more people out. And then the whole class does like a tournament. There's a bracket, and whoever makes like first, second, and third place gets a bunch of extra credit. So that's kind of a fun one to do like over the summer. Machine learning for trading was also pretty interesting, especially if you're interested in either machine learning or trading. You build like a stock trading bot based on technical analysis and like technical indicators. I think that stuff is kind of BS anyways, but it was a fun class to learn about finance and kind of get your feet wet, at least in machine learning, enough so that you can go out there and pick up stuff on your own. Some of the other ones like software architecture and design wasn't that good. Probably wouldn't recommend it. Information security, I mean, I guess all of them except for software architecture and design, I would recommend at least checking out the syllabus. The only class that I really didn't like and had gripes with was software architecture and design. And that was one where it seemed like there was, the reason why I say that is there was like not a lot of communication on what the grading criteria is on. So you were never really sure if you were addressing requirements. And so you'd turn something in and they'd be like, oh no, you actually missed this part. And then you go, well, that wasn't on the rubric or whatever. And they'd be like, oh, well, it is now, like that type. It was very frustrating and just unclear on what they were even looking for. I don't think that class has like been well fleshed out. It may be at this point, but the rest of them, I think, were all pretty strong. What was your other question?
Oh, it was in regards to like the whole math background thing.
Oh, math. Yeah, math.
Yeah.
So the most frequent math that I would say I was exposed to in the program was probably like understanding factorials and logarithms, which are more like pre-calc, I think. Those aren't really calculus. So you had asked, is it worth going to learn Calc 2? Calc 2, I guess, could be different things depending on what the schools are. I think in some sense you should understand like what the limits of series are, like how to represent like what the limit of a geometric series is or an arithmetic sequence. I never did integrals for the most part, or I don't think I ever like analytically solved an integral or anything like that. And linear algebra, I guess it's just kind of like the real benefit in linear algebra is that a lot of problems can be represented as like a system of equations, which is just rows of equations. And then being familiar with like what the linear algebra terms are. So if someone says the transpose of a matrix, like mechanically you have to understand what those terms mean. But I don't think that you're really doing anything crazy in terms of linear algebra or calculus. So I don't know if I would think if I didn't have that background coming in and I went to go look up that stuff as I needed to know it, that would be a feasible way of getting through the program. I don't know if I would necessarily like put off applying so that I could take a full course in Calculus 2 and linear algebra, because I think you'll definitely end up learning a lot, and 90% of it you probably won't touch in the degree. The caveat to that is if you go into artificial intelligence and machine learning, just by nature of what those fields are going to leverage a lot more calculus and linear algebra. And so I've seen some of that stuff. They will use like derivatives and things like that. But again, it's almost like they're well-known applications of calculus. And so, well, like what's a good example of what I'm trying to think of?
Is it stuff you could like pick up on Khan Academy if you needed to?
Definitely. Or I guess like you would not be the first person to,
yeah,
like gradient descent is something that you'll probably talk about if you're going to be taking those courses. And like if you just YouTube or Google like gradient descent method, then there'll be like 20 different people teaching you how to do it, And so you just have to learn like that one specific application of calculus. You don't necessarily need to know the theory behind why a derivative works or like the density of the real number line or anything like that, like esoteric concepts about why calculus works. You just kind of need to know how to like turn the wheel for a specific aspect of it to get the result that you want. I think that the more you know about why it works will make you a smarter person, but do you need it to be effective? And like, do you need it to do the day-to-day? I don't think so at all. And like, I wouldn't, like I said, necessarily sweat not having 100% of that knowledge going in, because most of the time you're like doing maybe factorials or logarithms are like the most advanced math that you might use, because like binary search and stuff like that is logarithmic and things. But there's lots of people in the program that had come from backgrounds that did not go as extensive into mathematics as like a physics degree or a math degree or anything. Those guys are there, but there's also a bunch of people that just did Calc 1 or pre-algebra, or not pre-algebra, pre-calc in college or whatever. And I think that they're doing fine. I obviously don't know that their grades, what their grades are, but they seem to be just as successful as anybody else.
Thank you.
Yeah. Let's see, anything else?
Sorry, I guess a really quick question. I
Yeah.
guess if you were to go back and do it again, would you have gone to computing systems still? Or
Oh, I think if I could go back and do it again, I don't regret doing computing systems. I'm curious and fascinated as to like what there is to learn in artificial intelligence and machine learning. And I think that would have been nice to know 1 or 2 or 3 years ago, because now obviously it's like the huge buzzword of the month. So you could probably parlay that into some high paying career if you had the knowledge at the right time. But I think just as a discipline, it's pretty intellectually engaging. So no, I don't have any regrets about doing computing systems, but maybe if I could do it again, I would check those out just because I'm curious. Would I do the program again? Definitely, especially now that I know like how to manage my time well enough so that I can kind of still try to do the things that I want. I think if I could really go back in time, I probably just would have done CS for my bachelor's degree. You know, because that's kind of what this ended up being, was a way to switch careers. And here I am at like 29 now, just kind of, I guess I'm starting a little bit ahead of where a new grad would start with a bachelor's degree, but you know, like I could have been 22 or 23 and in somewhat of the same spot as I am now. So I think I would go back and do maybe bachelor's in CS if I really could have a time machine.
definitely, thank you. I totally understand that, because probably by the time I'm done doing the program, I'm going to be around the same age too. I'm 24 at the moment, so
Yeah.
so
Yeah,
definitely
they
get
give you 6 years to do it. So as long as you don't take more than like 2 consecutive semesters off, you can spend up to 6 years doing it if you really wanted to. And it's also possible, like I know some people weren't employed for whatever reason, and they like were doing a speed run through the whole thing, and they did it in like a year and a quarter or something like that, a semester, which is also really impressive. My hat's off to them. I would not recommend doing that because you're gonna have no life, but if you really wanted to, you could speed run it.
Yeah, definitely. Thank you so much, Fred.
Yeah, just out of curiosity, is this 2A or 2B or 2C?
This is 2A.
2A. Well, good luck on your journey. Is this still C++?
Yep, still C++.
C++.
Yep.
Yeah, I learned a lot from Anand. I think he's a great professor. And I think that he has a lot to offer, and his advice is usually pretty good. So yeah, good luck, and try to fall in love with it, or at least be interested in it. And don't be afraid to crucially, pardon my French, fuck up when you're doing the projects and stuff like that. It's all part of the process. So
For sure. Thank you so much, Fred.
cool. It was nice to meet everybody. Thanks again.
Nice to meet you too.
Yeah, take care.
Take care.
Let's see.